the logical next question, just given the amount of information that we've covered and the amount of detail that we've been able to go into here as part of this discussion. I think the logical question people are going to ask is, okay, where do I start? What do I do first? How do I get the ball rolling on this? Let me kick it over to you all to maybe give some advice on what's the starting point and what are the next steps to take when considering these things.
Thanks, Tyler. So it's interesting, as we talked about earlier, some of these standards that are out there adopted by the various codes are minimum. These minimum standards are what's needed such that the designer, the contractor, and the suppliers just simply don't go to jail. But as stated earlier, guideline 42P that's out for public review from ASHRAE standard 62.1 is a higher performing building, similar to what LEED would recommend as a higher performing building, where increasing the minimum recommended code level in that area plus 30% gives you a LEED point. The well building standard, and I'm not sure if any of the audience have seen this, but there's a lot of advertising coming from the well building standard using A-listers like Robert De Niro and Lady Gaga and Jennifer Lopez and so on and so forth. But they're recommending of using standard 62.1 as the minimum, but in order to get one well point, you have to increase that number by 30%. To get 2 well points, you increase that number from the minimum by 60%. In addition, if you want 3 well points, you have to assure that you maintain CO2 concentration below 600 ppm. At 600 ppm, you're pretty much approaching the global steady state concentration, which is hovering at around 432 ppm outdoors. Now, why is that critical? Because we know that as we increase the number of people in a certain space, we increase carbon dioxide. So if we are able to maintain carbon dioxide as low as 600 ppm, we're probably approaching more than 60% out of minimum. In some of these areas, you can go as much as 80 and even 100% more outdoor air. Something that we've done in our training center at the Renew Air Factory is a DOAS system using 100% outdoor air with no recirculation. And in this training center, we can hold as much as 80 people and present on any topic, specifically when it comes to ventilation, of course. But when we do have that number of people, what we find is that we are never increasing CO2 concentration above 600 ppm. And you're talking about a classroom type environment where you've got tables and you have people seated about 3 feet apart from each other from the front of the room all the way to the back of the room. And typically, we've seen CO2 concentrations using the minimum ASHRAE standard as depicted by 62.1, elevating up to 2,000, 2,500, and even as high as 3,500 ppm inside a space that's that heavily occupied or at that density level. But increasing, once again, outdoor air lowers that concentration. But if you're lowering that concentration, you're also lowering the concentration of all the other impurities, whether you're talking about the particulate side, whether you're talking about the gaseous side, and then obviously lowering the concentration of any potential pathogen that may be within that space. So when we look at new construction as compared to existing buildings, of course, new construction is easy to prioritize indoor air quality as a design parameter. Of course, using ERVs and DOAS technology in the initial designs with your consulting engineer will make it super easy to assure that, yes, you're providing better indoor air quality and conforming to the energy standard, ASHRAE standard 90.1. Including MERV 13 filtration becomes very critical because a lot of these standard systems that you purchase, whether it's in an ERV or DOAS technology, or even a typical recirculation air conditioning or heating system, uses standard MERV 8. So prioritizing and making sure that you have MERV 13 within your design will assure that you are maintaining the airflow rates, because to what Rachel alluded to, upgrading your filtration from MERV 8 to MERV 13 does add a 20% penalty when it comes to static pressure. The second you increase static pressure, you lower airflow. And that's the thing that you do not want to do when you're taking into consideration SARS-type contaminants. When it comes to existing buildings, of course, it becomes a lot more challenging. Like I alluded to earlier, when you're talking about a school that may be 100 years old, that's just using hot water to heat the space with no ventilation, or even upgrading some of these systems that may have designed only 5 CFM per person, becomes a little bit more challenging. Challenging because, yes, your mechanical systems can't handle it, but even more challenging because where do you put these energy recovery ventilators, because there isn't any space on the roof or on the outside of the building. So you're trying to find that really expensive and hard to find real estate within the building walls. But what we should be looking at when it comes to some of these schools is compartmentalization. Look at possibly installing an energy recovery ventilator specifically for that one classroom. When we look at compartmentalization strategies, there's a few advantages for that. You can shut down a classroom and not operate your ventilation system and not increase operational costs, or more importantly, increase the amount of ventilation based on the density of that classroom as needed. Now, once again, we talked about increasing outdoor air. There are cognizant authorities such as WELL, Passive House, LEED, that give you recommendations to go above the minimum requirements. But once again, you also have ASHRAE 90.1, which is right there on the side saying, hey, you got to be careful on your energy. And then that's where using energy recovery will help you to ensure that you maintain within the guidelines as set by 90.1. And once again, because it's an existing building, yes, increase your filtration to MERV 13, but you got to be careful and watch out that you don't lower your airflow, because the increase of static pressure has a detrimental decrease in your total airflow rate. And then, of course, if it's possible, whether it's new construction or whether it's an existing building, upgrade your controls and add sensors. There are a lot of sensor technologies out there that will allow you to monitor what's going on within the space, because everything we're talking about, whether it's PM 2.5, PM1 even, or gaseous contaminants, you can't see them. When we're looking at a thermal conditioning unit, an air conditioning unit, or a heating unit, the second you turn it on, if it's really hot, it's the middle of the summer, you know if it's working or not. Conversely, in the middle of winter, you turn on your heating system, you know if it's working or not, because you can feel the hot air coming through your diffusers. However, when it comes to filtration, you don't necessarily see these contaminants, and you can't evaluate the delta of when it's on or when it's not on. Rachel alluded to the fact that she can feel the environment when it becomes more stuffy. And it's true, but that's like, depending on people's sensitivity, that becomes a personal thing. But as a school administrator or a facilities manager, using sensors, even just monitoring one parameter such as CO2, will help you evaluate, is something working or not? So if you see your CO2 within a space and a classroom that's being occupied up at 2,500 ppm, and you said, oh, you know what, we're going to design to well at 60% increase above minimum 62.1 requirements, and you're still seeing 2,500 and 3,500 ppm, you probably have a problem. So having that visual indication, of course, whether it's a new construction or an existing construction, becomes paramount on assuring the operation of the space and assuring the people within the space that, yes, they are getting what they're supposed to be getting. Of course, making sure that you look at preventative maintenance becomes very critical, because the second you have a fully loaded MERV 13 filter, you may potentially end up seeing a collapse of that filter, and now you're bypassing that air. So cleaning coils, making sure you've got the airflow, all of that preventative maintenance or just general maintenance becomes paramount on ensuring that proper indoor air quality. And in addition, especially when it comes to some of these older schools, you have like a nurse's office, which was just taken into the design as just another regular office and part of your general HVAC system. Or maybe it wasn't even taken into consideration, and somebody just said later on, well, we'll just make this office a nurse's station. Well, these areas need to be treated separately, and there are guidelines on how these areas are compartmentalized, or at least minimally structured in such a way that we have an exhaust system in that area so that you can maintain that area under negative pressure. But you typically can work with your professional engineer and evaluate your local code accordingly.